Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the cheapest flights within K stops problem. There are n cities connected by some number of flights. You are given an array flights where flight I is from to price. Indicates that there is a flight from city I to, from city from I to city to I with the cost price I. Makes sense. You are also given three integers, source, dest, and k. Return the cheapest price from source to dest with at most k stops. If there is no such route, return -1. Well, at least I understand today's problem. It's an improvement over yesterday. So here, for example, we're trying to get from 0 to 3 with at most one stop. So we can go 0, 1, 3. It's the only way to go that way with exactly one stop, but we could also go 0, 1, 2, 3, but that has two layovers. You stop at 1 and you stop at 2. So that exceeds K, so it doesn't count, even though it is $400, not $700. 0, 1, 2, we're allowed one layover, so that's fine. Going that way would be more expensive. 0, 1, 2 again would be better, but we're not allowed any layovers, so we have to take the 500 route. Okay, this is a Dijkstra's algorithm problem. So yet again, I'm going to import collections, and I'm going to do a fairly standard graph search. The heap is going to, in fact, no, I don't want collections. I'm going to import heap queue. I'm going to start just with source. No, it's going to be 0 source. So my representation of the data here is 0 is the cost so far, and this is the path I'm taking, while heap cost path is heap q dot heap pop from the heap. If path -1 is equal to dist return cost. In fact, now we need to do one check first. If len path is greater than k plus 2, continue. So that is our maximum hops check. So the reason it's k plus 2 is because we're allowed one layover, so the path is allowed to be of length 3. So if we've got 1, 2, 3, 4 nodes, we've burst our allowance. We just give up completely on this path. If path -1 in scene, continue. So I need a scene set. Scene.add path -1. In fact, no, that's not how I do this. Scene needs to be a dictionary. I'm just trying to remember how this all fits together for a Dijkstra's algorithm. So how exactly does Dijkstra's algorithm work? You take off the next shortest path and you try and extend it. I don't actually care. I think this is correct. For step in neighbors of path -1, heap q dot heap push heap for C step. So it's cost plus C path plus step. Return -1. I think this is correct. I'm a little bit unsure about the details here of Dijkstra's algorithm. I seem to remember something about recording all the costs of the intermediate nodes, but I'm not sure that's necessary in this case. This is almost a little bit more like an A-star algorithm, I think, than a Dijkstra's algorithm, but they're very closely related. Right, so we're just left with neighbors. So I did want a collections in the end. From to cost in flights, neighbors from dot append. Let's call that source. Oh, no. I've called it from, but that's a keyword, so let's just use underscore. I think that is correct. Let's give this a little test, shall we? Typo check effectively. Oh, no, that worked pretty well the first time. Amazing. I'm quite pleased with that because this is another video I'm recording in a little bit of a rush because I have to go catch a train. I think we're good to go. Let's click submit. There might be an edge case I've missed here. Wrong answer. Well, that's not really an edge case. N is 4. That's fine. Start at 0, destination 3. You can go from 0 to 1, 1 to 2, 2 to 3, but that's too many stops. You can go from 0 to 2, 2 to 3. Oh, that's what it is. I can't just do this business, can I? That's how Dijkstra works. I can't. Hang on, what's going on here? So when no, it's this K limit that's the problem. I did find the best way to get to 2. But I don't want to actually then prune that as a result. I need to maintain all paths. Let's try it without the scene set. Okay, it works without the scene set, yeah, because the assumptions that we're usually making in Dijkstra's algorithm are no longer valid effectively. Just because I found one way to get somewhere doesn't mean I found the best way to get there. Ugh. No, I need some kind of scene set. Scene dictionary. I think what I want to do is I want to maintain a list of no, what do I want to maintain? Yes, some sort of something that contains the thing that is the fewest hops or the lowest cost. Or something in between, I guess. For alts in scene path -1. No. If any of some condition that I'm still trying to work out. In fact, no, if all, but I'll come back to why I'm going to do all in a second. Continue scene path -1 dot append cost len path. So what we want to check here is the current cost path thing must be either cheaper or shorter than something that we've seen to be worth keeping. It's possible we've seen something in the past that has been completely subsumed, but I don't know. I'm going to turn this into a test case as well. $13, 10, 1, 10. Oop. 13, 10, 1, 10. So for CL, if it for every one cost is greater than or equal to C and len path is greater than or equal to L, it is no better than anything we've already seen. Yeah, but all defaults to true. No. I think that, so this default, if scene path is empty, this will actually default to true, which is not what I want. So I need to sort of say, well, make sure you're actually checking against something. Oh, don't need scene. I'm actually gonna break that over 2 lines. Okay, and we were fast enough this time with the final case. So let's see if that's fixed the problem. This is a bit weird. It would be nice to also eliminate the things that are no longer optimal from this frontier. This is sort of a semi-pareto optimal frontier, this scene collection now. It's not pareto optimal just because we're not removing things that have been subsumed, but it approximates it. So that, yeah, interesting problem. It's Dijkstra's with a little quirk on it because of this abandoning k. We can't just take the lowest cost path, or at least it would be difficult to determine what the correct metric is for lowest cost without this tweak on it. Anyway, that's it from me today. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time.